So in the last video when I talked about set builder notation, I wrote it as this. X existing in R such that X is greater than or equal to 2 or something to that effect. This is ugly. I don't like that. Let me redo that. With regard to this, it is not necessary that you write x's in R. It's just x such that x is greater than or equal to 2. It's not really a big change. I just want to be consistent with what the book is using, just so that you're not confused. This just means that x is a real number and x is greater than 2 or equal to 2. The other one just means simply x, the variable, and I don't know. It's just I'm used to writing things like this. And so that's why I wrote that. But it's not a big deal. If you write either, I'll be fine with it. I just wanted to point that out because I want to make sure I match up with the book. So for these ones, we have the following taking place. If you have a compound inequality, then what you do is you try to isolate the variable in the center. And so let's do that. We're going to -1 from this to here and to here. Negative 10 is less than negative 2x, less than or equal to 13. We divide by negative 2. We have 5 greater than x is greater than or equal to negative 13 over 2. So notice it switched the signs on both because I divided by a negative. We have that. Now what does this look like? Well, we have something like the following. We have 0 here. We have negative 13 over 2. And then we have 5. So let me go ahead and highlight that for you. Looks something like this. If we we're going to write the domain and range, we'd simply write negative 13 over 2 to 5, and we'd call it a day. That is like an and, so it means that it's trapped between those two inequalities. Now for this one, we have x over 4 negative is greater than or equal to 1 times by negative 4. We have x is less than or equal to negative 4, or negative x over 3 is less than or equal to 1 times by negative 3. X is greater than or equal to negative 3. So if I was to draw this, I would have the following. We have 0, negative 3, negative 4. And then now we're going to draw this. We have x is less than negative or equal to negative 4, which would be, here's negative 4. It's less than that, so it's pointing this way. I'm using the arrow to help me. Notice that looks like an arrow pointing that way. This one looks like an arrow pointing the other way. So I'm going to simply draw this. Now what does this mean? Well, the left side is going to need to tell us that x is strictly less than negative 4. So x is from negative infinity up until negative 4. Oops. But then we missed this part, so we're going to union it. And then we're going to start at negative 3 and go to infinity. So it's nothing new. You guys have done this before. That would be the domain of this. That would be a way to write it. Okay. We go to the next ones. We'll do one more, and then we'll move on to the absolute value inequalities. So I'm going to subtract 11a. Negative 7a plus 8 is greater than 15 minus, what? Oops. Minus 8. Negative 7a is greater than 7. Divided by negative 7. A is less than negative 1. So for the next one, we have 13 minus 14a. I'll just do it on this step because I'm going to run out of space. So I'm going to subtract 13. 0, negative 14a, less than or equal to 0 minus 3a. So this is negative 14a is less than or equal to negative 3a. So we add 3a. Negative 11a is less than or equal to 0. So a is greater than or equal to 0. And then we have the following. We draw our graph. We have 0 here. We have negative 1 here. Less than negative 1 would be this. Greater than or equal to 0 would be this. And so we have negative infinity to negative 1 union with 0 to infinity. Okay, and so that's taken care of. Now, we're going to move on to absolute value equations. No. Uh-oh, what is going on here? There it goes. Okay. So, we are going on to absolute value. There's a little trick to this. If you remember when you see a greater than or a less than, if you remember great or, that means it's an or statement like above. And if it's less than, then it's and, then it will help you do these. So, what I'm referring to is we have 3 minus x is over 5, absolute value of greater than or equal to 6. So this is a greater. I need two equations. So I'm going to first write the first one over 5 greater than or equal to 6. Or 3 minus x over 5 less than or equal to negative 6. So because of the or, I get these two equations. You just flip-flop them. You don't trap it between two things is what I'm telling you. And so if we have this, then we go ahead and solve times 5. 3 minus x is greater than or equal to 30. Minus 3 minus 3. Remember, the great or only gets rid of the absolute value. That's all it's intended to do. Negative positive 27. X is less than or equal to negative 27. Times 5 times 5. 3 minus x is less than or equal to negative 30. Negative x is less than or equal to negative 33. X is greater than or equal to 33. Okay, so you have two things going on here. Oops, we don't need that. Here's negative 27. This is strictly less than or equal to this. 33 is over here. This is strictly greater than this, or equal to. And so you'd have negative infinity to negative 27. Union with 27 to, or I'm sorry, 33 to infinity. Okay, so that is taken care of. Let's do a less than so you can see how that is operates. First things first, we still have to isolate the absolute values. So we have 6 is less than 2 over 3x minus 2 minus 3. So I add 3. You know what? I'm going to change the sign on this one because I don't think it's going to work out how I wanted it to. So hold on, I'm going to change this to less than because I wanted to give you an example of that. Okay. So we have that. And then we have 9 is greater than 2/3 x minus 2. Sorry, I've changed the problem. We're changing this to that greater than. So now I'm going to rewrite this. This is 2/3 x minus 2 less than 9. Okay, so we're good. Notice how I do this. This is pointing at that inequality, or I'm sorry, that absolute value inequality, so it still points at it if you flip the sides. Okay, this is definitely less than, so if we do less than, what we do is we set up two equations, or one equation, 2/3 x minus 2, less than 9, that's the original, and then you just put it on the other side, -9. We add 2. -7 is less than 2/3 x is less than 11 times 3. -21 less than 2x less than 33 divided by 2. -21 over 2 is less than x is less than 33 over 2. If we want to write this in the notation, then we have -21 over 2, but between -21 over 2 and 33 over 2. Okay, and so that is how you go about doing these. So remember, isolate the absolute value, say great or less than, but that only works obviously if this thing is in the front, so make sure you move that in the front. The absolute value has to be on the left to say great or less than, and so make sure you do that. Thank you guys.